I will present Dr. Cristina Sáez-Blázquez, who is going to be our next speaker. She is a mining and energy engineer with extensive research experience in geothermal energy and renewable systems. She has authored numerous scientific publications and is currently a Ramón and Cajal research at the University of Salamanca. Please welcome her.
Okay, thank you, Sergio, for your presentation. As he said, I'm Cristina from the University of Salamanca, but here with me is also Vasilis from the 𝗪𝗀𝗻 Technological and Cultural Park. Is also Raúl from the University of Oulu and Angelina from Frontiers, and also Tecnalia, who will be assisting online. So this is the session for the environment and waste management, and we are going to address some important points, like you can see here, some introduction about the problem that we will be addressing. The field pilot site in which we have applied our technologies. We will describe this kind of a system and the practical implementation, and we will finally make some closing remarks. So just to start with a short introduction, it's important to highlight the importance that the mining industry has nowadays in the supplying of raw materials for all the fields of energy, construction, technology, and so on. But it's also important to know the main challenges and concerns that we are still facing, like the land degradation, waste generation, and some important things that we have to take care of. So in this sense, I'm trying to manage these challenges in some waste management context. We have the application of different geotechnologies for the management of the following mining environments. We have two use cases in the 𝗪𝗀𝗻 silver mines that are in Greece, and the other one that is in 𝗵𝗂𝗪𝗻 mine in the north of Ostrobothnia in Finland. So the first pilot case, Vasilis.
Yeah, thank you, Cristina. From me, just a brief presentation of our pilots in 𝗪𝗀𝗻. 𝗪𝗀𝗻 Technological Park is situated in the southern part of Attica Peninsula, almost 60 kilometers from the center of Athens, established in the installations of the former French mining company of 𝗪𝗀𝗻. The general area was a center of mining and mineralogical activities for more than 3,000 years, starting from the ancient Athenians, and then one of the first industrial complexes in the newest Greek state in the mid-19th century. The main people that were involved in and contributed to the project from the 𝗪𝗀𝗻 Technological and Cultural Park and AMDC was Professor Dimitrios Kaliabakos from Mining and Metallurgical, the School of Mining and Metallurgical Engineering of National Technical University of Athens, and Vice also President of AMDC. My colleague 𝗚𝗪𝗪 Χαδουμέλης, Site Manager of 𝗪𝗀𝗻 Technological and Cultural Park, and myself as a Chemical Engineer and Environmental Consultant. Our first pilot site refers to a polluted soil repository, a unique structure that was situated within the park, within the borders of the technology park, in order to safely isolate from the surrounding environment thousands of tons of polluted soils from the area of the park. In fact, the repository contains more than 130,000 tons of polluted soils, safely isolated from the surrounding environment. Here is a view of the cover and bottom structure of the repository and how we have achieved the total isolation from the surrounding environment. And here is a 3D view of the different strata below and above the contaminated soils. And you can also see a view of the concentration of the metals within the repository, we can see that there are very large concentrations of specific hazardous and toxic metals like lead and arsenic, but also there are very interesting concentration of other metals that possibly can be examined for further exploitations from the waste, including iron, zinc, copper, and probably manganese. In any case, you can see that the concentrations are exceeding many orders of magnitude, even the lowest, even the highest limits for deposition in industrial areas. A very short view on the technologies that have developed in this pilot site. Our focus was on the exploration, classification, and the effective management of waste structures and the waste that included in the repository. And we have implemented, as my colleague Christina from 𝗬𝗏 will explain in detail later, specific technologies like drone magnetometer, ground penetrating radar, LiDAR SAM for 3D surveying, INSAR, satellite monitoring, and also IoT sensors for real-time subsoil control. The second pilot site that was not in the initial DOA but developed during the evolution of the project refers to an underground hazardous waste repository, also situated 15 years ago within the borders of the park. Our purpose is to use this area as a storage unit for specific waste coming from remediation activities, mainly from highly contaminated buildings within the area of the park. And the unique feature of this repository is that the only artificial underground hazardous waste repository in Europe, since there are other underground repositories in existing mines, but none of them is prepared artificially only for depositing hazardous waste. Is developed 40 meters below ground level and possesses an area of 2,200 square meters. Here you can see a view of the access in the area and also the placement of the waste in barrels that, if they are not disturbed, they may contain the hazardous waste isolated from the environment for hundreds of years. Our approach in this pilot refers to the validation of Muon telescope prototype and the Muon monitoring instrumentation, mainly focused on the density of the rock mass above the underground hazardous waste repository, which is very important for safety reasons. Here you can see a view of the Muon detector. And here is the final placement of the waste, where the last measurements from the Muon were also performed. Data obtained between December 2023 and April 2025 at 3 different locations. And we have managed, as we can see from Christina later on, to have a clear view of the density of the rock mass that may lead us to significant and very important conclusions and measures, if necessary, for the safe operation of the underground hazardous waste repository in the future. So that's all from me, I guess. So I introduce my colleague Raul for the Finnish pilot.
Thank you, Vasilis. Good morning, everyone. So I'm representing the University of Oulu. Of course, behind me there is a big group of colleagues that have worked on this project. I have to acknowledge them. And also there is someone who is not here from 𝗘𝗃 Institute who supported us with the pilot access. And 𝗂𝗃. Now, our purpose was focus on tailings embankments. And there are several reasons why we focus on that, but one of the main is that the structural stability is the interest for the mining companies. And the application of geophysics it hasn't been done. Normally we rely on sensors put on the ground and the continuous monitoring and measurements in situ. But with this technology, we aim to a non-invasive passive monitoring. We deploy two techniques, electrical resistivity tomography and also passive seismics. The workflow on how to use these techniques is well known, and also we use a lot in ore exploration. But the application in small footprints like tailings, I mean, in context, if we put into dimension, mining areas, they are in the range of kilometers square. But when we go into tailings facilities, they can be small footprints, like maybe 800, 900, 1 kilometer square in Finland. So the application of geophysics to that resolution sometimes becomes complex. So that was one of the objectives. The other objective was to automate the workflow. So in a way, rely less in human intervention and rather put the sensor, automate the workflows that starting from the data acquisition and the processing in the cloud. This is our concept. We have this first layer in which we deploy all these sensors. I'll pass through the way it worked. We deploy these sensors in two pilots, starting in 2024, dry season, and then we put also on the winter season when we have a lot of snow coverage and very low temperatures. And we tested several arrays with these sensors, and I would say we've been successful in the way we automate the workflows. The data acquisition was pretty much smooth. We work with the manufacturer to give us some control unit that can send the data to a server, and from there we could extract and do our processing workflow. So the results that we get is pretty much, in this case for the electrical resistivity imaging, is near real time. So it takes 2 hours data acquisition from the field, and then about 15 minutes, more or less, to do all the processing. So if we get this data, and we can program this, the settings in a way that we can get several readings during the day, but it doesn't make sense because this type of infrastructure doesn't change continuously. So even on a daily basis, we don't see much change. So we set up our frequency of measurements to a daily basis, and we get these sort of results, a tomographic view of the electrical resistivity distribution, which is connected to the pore water in the embankment, and that is connected depending on the range of that electrical resistivity to water infiltration from the impoundment towards the external face of the tailings embankment. And it has a lot of implications in terms of geotechnical engineering. With the other techniques, seismic imaging, we use passive sensors, passive geophones, different arrays, and the idea here is just use ambient noise that we have filtered in a certain frequency that pretty much is where we see more response from the subsurface on the embankments. And that ambient noise is processed. It takes several stages until we get what we are aiming, those seismic velocities. What we see on the right side and the lower end, those are the type of graphs that we want to obtain. Phase velocities that tell us what's the propagation of seismic waves in this type of embankments. And if we see changes over time, then we can infer that something is changing in the structure. And typically those changes are due to increase in moisture content or the saturation of the soil. Again, strong implication for geotechnical engineering and therefore for the structural stability of embankments. So this sort of information can, in this case, it was difficult to obtain like daily basis because ambient noise in an operation that have stopped everything. So it was a site, the pilot is under closure. There is no more mining activity. Only we have the noise of the trucks and also wind and some regional events in terms of blasting. Somebody could be building something or maintaining roads, but in this case we relied on regional events like seismic events. So we extracted just those segments and we processed this stacked over 7 days, and what we see is the response of the subsurface every 7 days in which we can rely. So yeah, so those are the two techniques that University of Oulu have developed, and Christina will show later on the images and the tomographies. Thank you.
Thank you, Raúl. So, from the University of Salamanca, with the support of Atelligence, we applied the drone magnetometry together with the 𝗪𝗏 UAV of Atelligence in the pilot case of Lavrion. We also use in both in Lavrion and also in Oulu the ground penetrating radar to see the state of the first subsoil layers. Then we also applied the LiDAR and SLAM to have, as we will see later, the 3D mapping of the different sites. The radar information through the INSAR techniques to analyze the possible ground movements and the subsidence of the mining deposits. And finally, we also use some LoRaWAN IoT systems to have a control and continuous control of the subsoil parameters. So here we are going to see a short video about the data collection in Lavrio. If it needs only So the first one is the magnetometer with the drone and the data collection in the surface repository of Lavrio. With this technique we can cover a wide area in just a short period of time. Then we have the ground penetration radar also in the surface repository of Lavrio to control the geotextile layer. And finally the SLAM is here also to cover the whole, the most important part of the Lavrion site and to have the 3D modeling. And then we have another short video about the data collection in the 𝗵𝗂 mine. So all the results from both pilots have been integrated in a WebGIS viewer in which we want to show the integration of data, how can they provide us with help and support for the pilot owners. So let's start with the pilot of Greece. We have the first use case, that is the surface repository. In this case, we have applied the GPR. As you can see here, we can see the different radargrams and the profiles that we have made in the site. And with this, we have developed a pottery viewer about the state of the geotextile layer. We have the possibility here of making different measurements and cuts like this. I can select a line, for example, this one, and I can see how this is the geotextile regarding the surface of the ground. This is important to see the different areas in which the geotextile should be recovered, or they should pay special attention. We have also deployed here the magnetometry, as I said before, and in this case we can see a 3D model of the different magnetic signals, in which let's wait, it's here, which we can see the areas of the site which have more magnetic signal, and that they should or they could contain more ferromagnetic or diamagnetic materials. That is also important for the site. We have also the interferometry that tell us some important information about the possible movements in the ground that we can have in this area. We have the possibility of analyzing all these movements in different periods of times. And also all the part of the IoT sensors. We have installed 5 IoT sensors in the most interesting part of the site. They have been measured from 2024. So we can here see how they are developing and compare the different measurements between sensors regarding the salinity of the soils, the electrical conductivity, and the content in different elements like potassium, nitrogen, and also the humidity. That can be important to see where the water is being accumulated in the site. Okay, and we have also the possibility of including satellite information regarding the different satellites, like the Landsat, the Sentinel, or different mining index. We have here the option of selecting an area, for example, here in the repository, and we can select also a date. Okay, I think the internet connection is not so good, so let's move on the next one. So the second pilot case is as Vasily told before, is the underground gallery. In this case, we have a 3D. Okay, I don't know if I have lost the internet. One minute. So in this second pilot case, let's see now if it works. Okay, it's now okay. We have a virtual tour of the gallery in which the user can access and have a general view how this site is and can move through it. We have also the product of the LiDAR and the SLAM, in which, as in the previous case, we can make different measurements and evaluate how the gallery is in the underground. And also regarding the muography and the results that they have deployed in this site, we have in this viewer, we can see the distribution of the different density points. As you can see here, we have the possibility of putting the ground, the point cloud of the ground, and also the density values that is important for them to see how the different materials with the different higher and lower density are located in the ground. And with this, we have also created a 3D model, a voxel 1, in which we have also here the ground in the surface, and we can make different cuts in different directions to evaluate how the distribution of density and how this behaves in the different directions. And finally, for this pilot, we have made a final model or recommendation for the owner. The first ones will be the magnetic susceptibility, that it's, we can show here the distribution of the low, medium, and high susceptibility areas. As you can see here, let's hide the ground. So we can see in an easy way how these areas are. We have here the high susceptibility materials that have a high ferromagnetic behavior, the medium ones that have moderate ferromagnetic pattern, and also the low ones that are more diamagnetic materials, and this is an easy way to see how they are distributed. They are also linked with the sensor, so they can see how this distribution is linked to the different measurements of the sensors, like the temperature, the humidity, and so on. And finally, we have the distribution of the geotestic layer and how these layers are more or less seen in the surface. The deeper geotextile position, that will be the blue ones, that are where the geotextile is mostly in the surface. The intermediate, and where this is near the surface. So regarding the other pilot in Finland, we have made also in the integration of the results in the WebGIS viewer. We had, for example, the seismic part that Raúl told us before. We have made this kind of viewer in which we can see how we have been integrating all the data, starting by the tomography, the seismic data, how we have the inversion of the data and the position of the different geophones in the ground, and how we have been constructing all data, passing for the CODA, and how the geophones of and the receiver fingerprint is in the different points, how good is the signal, and what is the frequency in each of these points. We have also the green function, in which we have also the possibility of selecting a geophone and see how is the individual green function in these points, and also the record section, and evaluating the signal in each point, to finally construct the 2D model about the density section of the part of the 𝗵𝗂 that they have been evaluated, and also through a 3D viewer where they can see where is the bedrock, the different parts of the site with different density values. The other part is the electrical resistivity tomography, also made by the team of Raúl and Oulu. And as Raúl said, they have made different data collection in different periods of time, so we can evaluate here the difference in resistivity, the distribution of resistivity and layers in the site. For example, in November of 2024, we have also, for example, April of 2025, and we can evaluate the difference in this resistivity distribution. Also, we can make different cuts and see how this is behaving in depth and in different directions. And finally, the work that we made there with the GPR, the ground penetration radar, in which we can see also the single radargram, so 2D profiles in the different points that we made the data collection. And we have also a 3D model about the distribution of the behavior of the radar the radar signaling depth, and also we can see how we have different areas with a different pattern distribution, and that could be due to different materials or water accumulation, and so on. And also here we have the possibility of analyzing the satellite data. Let's see if it works now. So we could select the area and the date, but I'm afraid that the connection is not working now. So I think this is the most important of the WESGIFs, and we can't go on with the presentation. And now, Angelina.
Thank you. Good morning from myself as well. This is a very short introduction into a software engineering platform that is addressed for users that work above the ground, that they have jobs such as business process manager, people who are tasked with business processes optimization, people who are doing administrative jobs for the various mining sites, or in our case, the waste management site in Lavrion. And it's the question that the research question that we have liked to address is the fact that how can we take already established business management, business process management techniques in order to make them additionally decentralized. How do we have people collaborating between themselves, have let's say a contract among them on how to manage, how to enable them and to empower them to have interactions between them without having the need to use a mighty third party in order to establish trust between them. So what we did was using an established process which is designing business processes with a well-known standard called the BPMN2. We use this, you will see an example just in the next couple of slides. What we are doing is taking a business process, modeling it with little boxes, little lines that you can see how the business process evolves over time. We can simulate this. It's as it happens in the real time. So, in fact, it's let's say a digital twin of the business process. We have used a technology that it was already mentioned in some previous slides. That is the blockchain, in order to achieve signing of business contracts between two parties without intermediaries. The business platform also allows people to assign work orders, the one among the other. And what the blockchain is used for is to establish, first of all, visibility and accountability, and see where a process is stuck. If it's delayed, see who delays it, or who is the next responsible of solving an issue. You can reiterate and see the history over time, and see for optimization reasons, in order to see where business processes usually get stuck or have issues. You produce a kind of heat map, let's say, so you can see where there are problems in order to optimize them. So discover bottlenecks, in other words. And as I mentioned before, there is traceability because logging happens at a low level, and it cannot be falsified. This is what the blockchain allows us to do. This platform is a product of collaboration between three companies. The first one, the upper part, the business process manager part, has been developed by the company I represent, the Frontier Innovation Center. The smart contracts manager has been developed by GFT, and the blockchain infrastructure in the context of this project has been deployed by Technalia. The business value we introduce, maybe what is like I would like you to take home from today's presentation, is the fact that this type of This type of deployment allows for operational transparency. It allows feedback loops, and data analytics allow the bottleneck tracking. So you can have a continuous process refinement. You can have business partners that work together, but they base their collaboration on business trust. But okay, it's a third party, it's outside your company. How much, where this trust stop? So it allows those people to collaborate without the need for a third party. So you have a kind of self-governance. You can streamline compliance tasks, so you have reduced costs. And then, as I mentioned before, you can have a full transparency and accountability. We have used this platform in 3 different pilots of Mineio. It has already been mentioned earlier by the presentation in the Freiberg mine that we applied this in the context of a predictive maintenance use case, for instance. But for Lavrion in particular, what we have modeled is the business process of fire permission renewal process. As an underground facility, the waste management facility needs to obtain from the state certificates on its safety every 5 years. It was, yes. Thanks for this. Every 5 years. So here you can see an example of a business process being mapped. The various swimming lanes, as they are called, represent different partners. Different partners can log in with their own credentials and see the task assigned to them. You can see where a business process currently is. You can, for example, in our use case, you can fill in the forms, you can upload the material that is needed to obtain fire permission. You can get notifications via email or in whatever method you choose that something is ready and waiting at your inbox, or that that an answer is expected of you in the process. And the various users that are represented in our case is the waste management facility owner, it's the state, it's the fire department that gives the permission, and so on. And this is a small video. It's very brief, just a few seconds, where you can see what actually the person sitting at their desk can see. They can see the business process travel around as. Of course, this happens in a few seconds in what you see, but this happens over days or weeks, depending where the process currently is. And people get at particular events their notifications that they have to do something or that their application has been approved, and so forth. We have a few seconds more. And the next and final slide has an example of one such email. It's the last one, where it says that the fire department has given you the approval that you are waiting. You can download it from there. And the first 2 are example of forms that the various people involved in the business process needs to fill in and send between them in order to exchange documents. And before closing, I just need to share that also the exchange of documents is decentralized. The documents are not saved in somewhere in the cloud. It is saved in the people who are exchanging, in the computers of the people who are exchanging the documents. So you have an extra security layer there. So this is it for me.
Okay, thank you very much. We have issues with the microphone. What I wanted to show is that from Tecnalia, we have cooperated by making deploying a blockchain system where we use a 𝗵𝗫 blockchain network, which stores different kinds of data depending on the use case. And as it has been previously indicated by our colleagues, the different benefits of blockchain and its transparency and consistency in the data that is recorded. We use these benefits to make a platform where users can add new information or save it in the blockchain, and then can query it or consult it for different uses depending on the use case. However, these systems not store large files in an optimal way, so we have made use of a decentralized file system, which is IPFS. The objective of this is to displace or to make an optimal usage of file storage, and so blockchain can refer to the location of these files in this system. We also have contemplated the possibility of using alternative file systems, so this will be quite that it should work with different kinds of storages, but we ourselves have used the IPFS for this project. Can you pass to the next slide, please? Also, to optimize the querying and filtering of data, we have used an off-chain indexer. The objective of this is gathering the data from the blockchain network in a way that we can determine key events or key information that wants to be consulted. Taking, for example, the use cases of Lavrion and from Oulu. In the case of Lavrion, we have focused on the on registering mining operations and the amounts or the proportions of mining materials or waste that have been generated. This way, a user can consult the events of mining operations and gather the information that assesses the amount of different materials that have been generated, and filter it according to the kind of material or the kind of data they want to filter it by, be it a user or a date, for example. In the case of Hulu, the usage of this traceability platform focuses on following the transference of documentation and ensuring that the necessary documentation and legal documents used for the mining operations are correctly transferred and assessed. And in the overall, what we want to do is combine these different elements, do this solution that can be accessible for different profiles, whether it be users that want to upload new data or users that want to consult it. And we have deployed the demos for both these use cases. This will be all from my part. Thank you very much.
Thank you, Xavier.
Please, Christina.
So just to finalize the sessions, as closing remarks, like highlighting the importance of redefining the mining intelligence and application of the new technologies to help to characterize this environment, all the digital transformation that has to be implemented, of course, to have the new paradigm of the mining industry, taking data to real-time insight and try to combine all the results that we have to characterize the environment. So I think this is all from my side. I don't know if there is time for any question.
Okay, coming back. Do we have any comments or questions here in the room? I will have one of my own then. You presented perfect results and the way of picturing those. What other data can be incorporated in this kind of graphical form? Can you elaborate?
How can they be incorporated?
No, another additional data. Is it straightforward?
Yes, it's not a difficult point. The worst thing is to process in a platform that can be adapted to the WebGIS, but it's not. It has not been difficult because we have been working with the data of Raúl that were external, and it's not difficult.
Yeah, we have seen different kind of data presented in a 3D form and from different sites.
Yeah.
Microphone, please.
Sometimes it's very difficult to incorporate all of this data. I mean, especially for Lavrion, we have gathered tons of data from our field work. For example, from Muon telescope, we have a very large number of data that should be combined together in order to have a clearest view of the density of the rock mass, both 3D and 2D. Okay, and it's very difficult, you know, in a very short presentation to show the volume of this data. I mean, it's enormous. But the results and the remarks, you know, that Christina presented now, are coming from the evaluation of most of these critical data.
Yeah, of course. It was stressed by Jan in his entry presentation that basically we are seeing a kind of a snapshot.
Yes,
so a concise,
less than a snapshot.
Less than a snapshot. Compressed snapshot,
Exactly.
if you will. Okay, thank you for now. I think we will adjourn for lunch. We will try to meet 10 to 1, so 1250 is our starting time of the next session. Thank you and see you back again in a few minutes.